Now let's make a new geometry. Inside the geometry, let's make a planar, and let's make this planar zx. Let's reduce this number, maybe 0.05, and let's make a transform. Let's go to the y and choose channel, not channel, motion fx and wave. So let's see what we got here. We got very fast motion. Let's make it like this. Offset at amplitude, it will be less higher. Let's make it fast a little more. I feel it's very maybe something like this. Okay, this looks good. Back. Okay, now we have a movement in the y direction. Now let's add a Vellum constraint configure clause. Vellum configure clause. Let's hide the show guide. Also, let's add Vellum solver. Now if we do play, it will fall. So first of all, let's add a pin animation like this. Let's add this as a brush, maybe this, and hit enter. Now we have those points here. If we hit play, it will stay the same, this point that we choose, but we will choose match animation so it can move with the animation, as we can see now. Yeah, perfect. Now let's see what we can do here more. As we said earlier, we discover the stiffness drop off decreasing, and now let's choose the increasing. Okay, so I will put 2. Let's hit play to see what's happening. As we can see here, there is stretching happening, then it's stay. After this stretching happening, it's back to its original to its receipt angle again. So depending on this number that we will put here, it will make the stretch. If we want a big stretch happening, okay, with the movement, we will increase this number, maybe 4. So until it reach this number, it will stretch until this number. So basically this is stretching for 4. Okay, and then the receipt length scale, I think, will take over again and it will shrink again. So we have stretching then shrink. Okay, so this is basically what's happening for the stiffness. It started from this number. It allows this number to be stretched until it reaches this number. Then the full stiffness will take over, and it will stay at its original height or original receipt angle scale. Okay, as we can see here. So if we want more stretch, we can add 6 and play again. as much as we add numbers here as a stiffness or as a stretch, it will stretch with us until it reaches this number, then the full stiffness will take over. Okay, as we can see it stretched, then it's, we can check here, maybe we can choose visualization, stretch distant. Let's see what we got here. 0.01. Yeah, maybe we will make this number a little bigger to see what's going on. Yeah, okay. So as we can see here, there is a stretching happening here, and then the stretching is over, and then stretching started to happening again, and it's over. So basically it's stretch and shrink, stretch and shrink, and as many or as height, as big the number that we put here as the stretch will be. Okay, so this is basically the stiffness drop off. So let's see another sample. Now we have a tube, as we can see, nothing fancy about it, just a tube opened and closed from the two sides, no end caps. Also I think I can add a little more from this one. We'll make it 25. Okay, this is first. Of course it's better to add a remesh. Maybe we can add a remesh more for it. Let's see, 0.1, let's see 0.5. I think 0.5 looks good. Maybe a little bit, 1.3. Yeah, something like this. Okay, on the other side we have just a tube with end caps, and then we have a bend, as we can see here. Of course the bend I choose set okay, let me do it for you one more time just to see the steps. Okay, this is a bend, right? We need this bend, but as we can see the bend is in the wrong side. So basically we go to the set capture region, and maybe we can hit space 3 and simply just from the top to the bottom in a straight line, and that's it. So now we have the bend, as we can see here, up and down. So we can just simply put a keyframe here, 24, other maybe we put 100, other keyframe, and here minus 100, put a keyframe, and the third one it will be 0, put a keyframe. Now let's hit shift enter, hit F to have to frame what we have here. First of all we need those two to becoming a linear, as we can see. Second, we need a continuous motion, right? So how can we do this? Simply just go to the channel list, choose channel properties, choose after, choose cycle after. So this is the after and this is before, and hit apply and accept, whatever, this will work. So as we can see here now, we have just the animation that we did here earlier. Okay, let's continue. Let's make a Vellum class, configure class, and of course this one will be the collision, so we add it here, and then we have a Vellum solver. Okay, as we all know, if we hit play, this will fall. As we can see here, it will fall. Yes, it will collide with it, but it will fall, right? We don't want that. We want to stick it to this one, stick on its place at the top. So go to the animation, pin animation, split 3, maybe add this circle, select rectangle, hit enter. Now we have a pin target, space 1 to go to the perspective. Also, I don't want to see the show guide geometry. Let's hit play again and see what's happening. Yeah, as we can see, it reacts with it, and this is what we want, right? Maybe I will make it a little longer. I want to make it from here, maybe. Yeah, maybe something like this. Okay, so now we want to test those enable wrap and weld, okay, in this lesson. So if we check it and do again, I don't see really much happening. So first of all, as we can see here, we have something called material UV. So basically it required a UV attribute. As we can see here, we must have a UV attribute. Here we don't have any UV attribute, as we can see if we hit space 5. Okay, space 5, space 4. Not sure why it's not working. Anyway, so here I will add UV project, and since we are working in a cylinder, so we will use a cylinder. Yes, as we can see here, now we have a UV, but the UV here is in the vertices. If we check here, we'll find the UV is in the vertices. We need it in the point, so let's convert it here to points. Now we have the UV. Now let's play with those number again to see the difference. Let's first make this like that and make 0.1. Let's see if there is anything happening or not. Okay, it's all, as we can see, it's all fall down. Actually, that looks cool. It's all fall down, but we need to specify the vert the I think this one to close and UX. I think this is U, so this will be the vertical, and the other one is horizontal. I think this one is the vertical. So if we make this one like this, let's see the difference. Yeah, but we will reduce this number, maybe just sorry, maybe just 0.1 for now. Yeah, so as we can see, this is stretching in the vertical, only in the vertical. As we can see, the stretching happening in the vertical, right? As we can see, there is no, maybe we can reduce it a little more to see better. Yeah, as we can see, there is no stretching in the horizontal, only in the vertical, right? It was like this, and suddenly it's full more. We can make a little more to see more different. Yeah, as we can see, only it stretching in the vertical, right? Okay, so let's see if we opposite this one will be 0.01. Let's see. Yeah, as we can see here, there is not much stretching happening, right? So maybe if I can put another one here. Yeah, there is something I should write here. It's UV. I should write the UV here. I'm sorry, totally forgot. Yeah, so I'm not sure if there is really stretching or not happening. Let's see here from the visualization. It will be stretch distant. Yeah, some stretching as we can see here happening. Okay, so basically this is the difference between rep scale and width scale. I'm not sure why they name it those two names, but basically this is for both of them. Okay, but we have to confirm the UV material. Actually, it was working without, I don't know, it was working without putting a UV, but I think we should referent to the UV. Okay, so shear, we have also a shear. Let's say if we put it 0.1, let's see what's happening. This is a UV attribute, UV projection. I think it's F space 6. Okay, yeah. Now I'll select them again, and maybe just rotate them like this, and make them like this. Okay, so space 1, and let's see now. Maybe I'll put here 0.01. I will put here 1. Let's see again what's will happening. Oh, I'm sorry, I have to choose this one. Maybe I'll hide this for now. Let's see again. Well, from the UV, as we can see from the UV, there is this one is stretching, but this one is not stretching. As we can see here, this is not stretching, right? From from those boxes, if we go here, maybe you can see it like this. Stretch distant. Yeah, exactly. So basically one of them are really stretching, but the other UV that we rotated, it doesn't stretch much, as we can see here now, right? So the UV control it. Okay, if we want to do a specific shape or something, maybe this effect will help.